weird couple of days. I am so sorry to put a test on you. But we got together, well, we didn't get together. It was like so many emails. It's been crazy this week, or this whole weekend. Been doing like 3 weeks worth of work in this weekend just to kind of figure it out. So the people teaching stats, we decided that in order to be able to kind of properly get you a grade that will work for transferring, right? So if you're using this course to transfer, which most people are, if you're using it for, future whatever prereqs, which most of you are, right? There's certain guidelines that we need to follow, and so that's why we have to have this test. And I know it's mean, and I'm so sorry. It will just be on chapter 6 and 7, so we're going to wrap up chapter 7 today. And what I've decided to do is, and that's why I brought some extra formula sheets in case, is that for the test, you can bring your own formula sheet, and you can have whatever written on here that you want. Okay? I think that's kind of fair-ish. Still not fair, but fair-ish, right? So less material. You will still want to keep your pace up, right? And so, because it took me about 25 minutes to write. So if you triple that, you're still going to be kind of going pretty fast, right? And so, so you want to make sure that I know you've got a lot of other stuff, and I know I'm not your only course that's putting a test this week to try to get it out of the way, but yeah.
Is there other practice? I think the class you mentioned that we didn't know was on, but that wasn't going to be on the test, and we practice testing the question on it.
Yeah. So the reason for that is because we were supposed to go into chapter 8 for the test. And so now just to do kind of like a touchdown point, okay, here are the things that we have covered that I could, so yeah, so that's new, right? I think what you'll find is that it's still pretty reasonable, right? And so, because you did that big one on the assignment, right? It was kind of long if you didn't use Excel, so yeah, thank you. That's a new one that will be on there. I think it's only 4 marks or something like that though, so it's worth doing. It's definitely reasonable, right? I'll give you a rate. You'll know it's Poisson because all I tell you is the mean rate is this, right? And then I ask you the questions, so that's how you know it's Poisson. And also, I say which type of question it is on the test, okay? Just to point you in the right direction. Don't know why I did this. No other teachers are listening. Like, you need to get your grades high. So what I'm using this test for, even though it doesn't feel like it, I know it doesn't feel like it, I'm using this to bump your grades, right? So that I can be like, hey, I legitimately tested this in a classroom setting. We all agree that those are great, right? And see, they got these high grades. So that's what I'm hoping for. Okay, so that's what I'm going for. So I don't want you to be scared. I want you to work hard this week because it's going to be a tough week. But we just need to get through it. Okay. And then after Wednesday, we'll go remote. So what we've decided is that lab 8 is going to be kind of a bonus lab, right? So do it, see how it goes, right? But we won't meet for lab on Friday. So let's see if I can kind of summarize that somewhere here. Maybe I'll put a page in here. March 16th. We'll kind of insert them in our pages here. And so test number 2 is on Wednesday. And not to alarm you or anything, I think you can maybe tell it's probably one of those things where it's just in your head. I have been working all weekend. I am feeling a little bit sick. I think it's maybe like just stress, but sorry guys. So if I get worse, then I'll have someone else come in and invigilate the test on Wednesday. So just as a heads up, but I think it'll be okay. So test number 2 is on Wednesday, and you may use your own formula sheet with whatever you want on it. With whatever you want on it, okay? But you do have to use the actual formula sheets and kind of write around it. So I am making it a little bit harder, but how small can you write, right? So, and there's a back page too, so you can use that. And so you can grab some, or grab a formula sheet from me. But hopefully everyone that's here got one. And that's why I said I'll let you decide later if you need to grab a fresh one. You can always have 2 and kind of see what you want to put on there. So there's more up there for later. But for anyone who's kind of watching this later, you can come grab one if you want, or they're posted on Moodle too. Okay. Poisson will be on test number 2. You can do it. You got this. All right. Anything else that I kind of mentioned there? We've got all kinds of handouts still, so whatever you need, just let me know. I know it's short notice, but you've got it under control. Okay. All right. Any questions before we keep going with? Oh, yes.
I have a quick question. For the Poisson question, will we need to calculate the range as well?
No, it'll just say the mean rate is this. So if you're looking at the, I didn't pull it in on my iPad, but if you're looking at the formula sheet, so I put the list of topics, but as long as you know how to answer all the questions on the back, you will be good. Okay. What I did was I made the test because that's how I find it's better to do. And then I made the practice test. And I just kind of, okay, yep, good. Okay. So it starts with what I would call a Zed score question, right? And so, and I'll keep the same order too, just so I don't throw you off. But so on test number 2, question 1 is what I call a Zed score question. So how that one's gonna go is usually there's a part or 2 about just calculating Z scores or probabilities with just one observation, right? And then I say, okay, now you collect a sample of, so in part C, right, it says you sample 50 West Indian manatees. What's the sampling distribution of their average speed X bar, right? And so now you've got a single observation is when you use Z equals X minus mu over sigma. And then you've got the sampling distribution is X bar follows a normal distribution with a mean mu and a standard deviation sigma over root n. And then we find a probability for the means. So then for a mean observation, Still uses a Z, but Z equals X bar minus mu over sigma over root N. So that's how that first question is gonna go. Question 2. Assuming the probability that a manatee is struck but not killed by a boat in any year is 0.57, right? So here, all you're given is a probability, and you can boil it down to a success failure. Success in this case is the morbid, he's struck by a boat, not killed, just struck. And so this would be a binomial question. Question 3 says the mean rate at which a calf, which is a baby manatee, feeds is 6 times per hour, right? So I give you the mean rate, and so that's all I give you, and so that's gonna be the Poisson. And then question 4 is a biggie. It's gonna be a confidence interval, a sample size calculation, and a hypothesis test, which we'll finish right now. Okay? And so it's going to be later, because we will go beyond this, but later we're going to refer to this type of question as one sample mean, sigma known. Okay? So that's what I've called it, right? But it involves confidence intervals, or a confidence interval. Interval, calculate N, right? So find the sample size, and a hypothesis test. And also it finishes with a decision error question, which we'll talk about today. Okay, so the p-value, you use the Z table for these questions, because the p-values are probabilities, right? And so, and I'll show you how to do it in the example that we're gonna do. And so, but yeah, so we've already been calculating p-values because they're just the areas in the tails, right? And so you use your Z table to find these probabilities. And so let's just kind of skim backwards here. So that's kind of our, I guess this is still a review, right? But when we do the test, we calculate some test statistic, right? How far, and we're gonna just calculate Z for this test and for now, right? How far is our sample mean from our hypothesized mean, taking into account the standard error of the mean, right? And so we calculate a Z, and then in part 3, or step 3, when we find the p-value, right, that's when we find the area in the tail from Z. So if Z is on the lower end, we find the lower tail. If Z is on the upper end, we find the upper tail, okay, which I know will make more sense once we get to that example. But let's just talk about the rest of it. Then, yeah. Any other questions though before we do?
No MCQs.
Yes. 4 questions. Pardon?
There's no MCQs.
No, no multiple. It's all just long answers. Show me what you got. Part marks available. Right. So, yeah, no multiple choice. We're moving on. Just big stuff. Right. All right. So we started talking about last day, right? But so the p-value is going to be the area in the tail. And for all these questions, I mean, I've made up these questions. There's, I think, one somewhere where I get you to actually think about which area it should be, but it'll always just be in the area in the tail. Because the p-value is the probability of seeing something as extreme or more extreme than what you saw, right? And so here, I'll just highlight this, because p-values are kind of this weird beasts that take a really long time to kind of tame, right? And so we'll need to keep working on those. But for now, just kind of sit back, relax. Know that p-values are something that you should know something about later. Okay, so like I said, it's going to be the area and the tail. And if we think about, okay, we collect a sample and we want to compare it to some hypothesized mean, this sample mean, it can only fall on one of the sides of the hypothesized mean, right? And so if you've got a mean from your sample that falls, say, let's say 2 standard deviations below the hypothesized mean, right? Then your p-value would be the area to the left, right? If you're above the mean, so now you've got a positive Z-score, then you want the area to the right, right? And so that's why we spent all that time, you know, working with the Z table, figuring out our Z scores, finding probabilities. It was to be able to find these p-values. What happens if we need a 2-sided p-value, which remember is if your alternative hypothesis has a not equal to in it, right, then you're going to find a Z-score down here, let's say. You're going to find this p-value, and then you're just going to multiply it by 2 and pretend it happened on the other side. So it can't happen in both, but we just find our 1-sided p-value, multiply it by 2, and that's your 2-sided p-value. Okay. Well, like I said, make more sense once we flip the page to the example. So let's talk about the conclusion. So we're going to use our p-value to draw a conclusion about our hypothesis. Okay. One thing that's important is that we do all our testing assuming the null hypothesis is true, right? If you go back to the formula that we used, the mu that we're using here, h naught mu equals mu naught, right? Mu naught is going to be replaced by some number since we've just collected one sample and calculated the mean and we want to compare it to some number. That number is your mu naught. Okay. So here, what's important is that we do all our testing, right? And by testing, I mean calculating our Z-score. We're assuming that H naught is true. So we do all our testing assuming H naught is true. Right? H naught says that use mu equals mu naught. Right? And then, so that's what we do throughout our whole procedure here. So what's important to tie this back to the conclusion, our conclusion has to be in terms of H naught. Okay? So let's go back here. So it's important, kind of down at the bottom-ish, it's important that we state our conclusion in terms of H naught since we have done all our testing assuming H naught is true. So what happens is, how do we land on a conclusion? Well, we need some sort of threshold. So remember, we can think of, and just think of the p-value as the probability that the null hypothesis is true, right? So if we find a small p-value, right, then the probability that the null hypothesis is true is very small, right? If I told you, oh, the probability of that happening is, 0.0002, you would say, probably not. More likely that something else is going to happen, right? And so we use the same idea, right? So if the p-value is small enough, we have enough evidence to reject H naught in favor of HA. So that's going to be the wording that we use. We either reject H naught or we fail to reject H naught. Okay? we either reject H naught or fail to reject H naught. I'll put a note kind of down here where I have a little bit of space. We never accept a hypothesis. Okay? There's always a probability that we're wrong. The p-value is the probability that we're wrong, right? And so we never accept a hypothesis. I'll even put an exclamation mark. Right? There's always some probability that we're wrong. Okay. So what we do is, okay, well, if the p-value is small enough, fine. But how do we know what's small enough, right? We need to say, okay, if it's smaller than this, then I'm going to reject H naught in favor of HA. And so what we use there is the alpha level. So here's the alpha level. If the p-value is less than the alpha level, then we have enough evidence to reject H naught in favor of HA, the alternative hypothesis. If I don't give you an alpha level, the default is 0.05. Right? So just as a default, it's 0.05. And we already talked about it kind of when we said, okay, the default confidence interval is 95%, right? 95% confidence, it falls somewhere in here, right? Or there's a 5% chance that I'm wrong, right? So they're linked like that. And so 95, 5%, 95% for the confidence interval, 5% or 0.05 for our alpha level, that's our default. Okay. So there's only two options, right? If the p-value is less than the alpha level, then we have enough evidence, because then we're saying our p-value is so small, right, smaller than this 0.05, right, that we can reject H naught in favor of HA. Or if the p-value is not less than the alpha level, if we haven't moved past that threshold, then we do not have enough evidence to reject H naught, right? And that's the end of it. But notice how we either have enough evidence or we don't have enough evidence to reject H naught. That's going to be your key, right? You don't want to be jumping around between your alternative and your null hypothesis. And so you either, we have enough evidence to reject H naught, or we do not have enough evidence to reject H naught. So I want you to use that same blurb kind of regardless of whether the p-value is less than or greater than, just change, well, negate it if you need to. Right. So then your conclusion is going to have three parts. First thing you're going to say is you're going to explain to me how the p-value compares to the alpha level. So usually we say something like, since the p-value is 0.0002, it is less than the alpha level of 0.05, right? Just establishing that it's less than or greater than, depending on the scenario. Then you can draw your conclusion in terms of H naught. Therefore, I have enough evidence to reject H naught in favor of HA. Right? And then what does rejecting H naught mean in terms of the question? Right? And I know this is a lot, and I warned you about it. Remember when we thought we had time in this course? Man. I warned you that it was going to be kind of a whirlwind while we go through these general steps, and until we do an example, it might not click quite yet, but that's okay. Just be patient. So I think we're ready for this example. Let me see here. Yeah. So the difference between a hypothesis test and a confidence interval, just to kind of reiterate, hypothesis test is when you want to show that, okay, because of my sample mean, I'm able to conclude that this is significantly different from my hypothesized mean. But it doesn't tell me how different. It just says, well, it's significantly different. Whereas the confidence interval actually gives me some range of plausible values where the population mean might be. All right. Sort of, somewhat. I'm using the same example just so we have a kind of an idea of what's going on. Right? So we're looking at the DMS odor thresholds for wine tasters. And just for individual adults, it follows a normal distribution with a mean of 25 and a standard deviation of 7. Okay. We would like to know if wine tasters have a lower odor threshold than the general population. We suspect that they do, but we collect a random sample of odor thresholds for 30 wine tasters so that we can confirm our theory. We find that their mean odor threshold is 21.5. Okay. So how these questions are always going to go is I'm going to have to give you a sample mean, okay, 21.5, and then there's going to be a value somewhere in the question that you want to compare your sample mean to. Okay. And so we want to compare our wine tasters, the mean of 21.5. We want to compare that to the population mean of 25, right? So here, this is the value we want to compare X bar to. Okay. So your first plan of attack for these questions is figuring out what your sample mean is, right? Convincing yourself that this is your sample mean. I would say that's your step one. Especially now, because later on you'll have to figure out, okay, do I know the population standard deviation or not? In this case, I do, right? So that's what's making it a one sample mean sigma known question, because I know that sigma is 7. Okay. So the first thing you're gonna do, I'll put a little 1 here, is figure out what your sample mean is, just so you don't keep it and mix it up with the other stuff. Okay. And then step 2 is find the value you want to compare X bar to. Goodies. This is your mu naught. Okay. So that's the value that you want to compare your sample mean to. Okay. So there's going to be a sample, so there's going to be 2 means, right? A sample mean and then some hypothesized mean, some value that you want to compare your sample mean to. And you essentially, you want to see, is this 21.5, is it significantly far away from 25 to say, yes, there's a significant difference here. Okay. So in our first step, you're going to set up your null and alternative hypothesis, right? And if you kind of use your formula sheet as a crutch, oh, I think I got one here actually. If you use your formula sheet, it's got some stuff on it, right? So if you go to the back page, then on the left-hand side, there's hypothesis testing for the means. Oh, I wonder if I have it in here. Formula sheet. Look at me go. It's like I've done this before. All right, so now I'm on the second page and I'm looking down here. There's going to be a little crutch here on our test, right, we're working in sigma known, right? We're pretending to know that sigma is 7. Okay? So for our test, that's the only section that you need to care about for the hypothesis testing. And let's do the same for the confidence interval, right? Again, we're talking about sigma is known. And remember last day we said, okay, well, we can calculate a confidence interval. We can also calculate the sample size that we would need, right, to achieve some desired margin of error. And there's a practice on there. Right? But these are the only 2 sections that you need on the back page. Right? So I want you to just kind of zoom in on those, ignore everything else. They all look kind of similar. It's all a blur, right? And so here, you've got your null hypothesis, right? But your null hypothesis is always going to have an equal sign in it. We talked about that. It's always going to be kind of nothing is going on here, right? We're saying that the population mean for wine tasters is the exact same as for the adult population. We suspect that's not the case, right? But that has to be our null hypothesis. So what we do is we have to replace our mu naught with the number that we got from the question. Right? So in our case, right? What you would write for your null and alternative hypothesis. So for this one step, this is all you need. Right? So this here answers step 1. That's where you have to state your null and alternative hypothesis. So you're going to say, okay, well, my null hypothesis is that mu equals 25, right? Because we pulled that number, that 25, from the blurb. And so this is all we need. All we need in step 1. Okay. I've got other stuff going on, kind of guiding you through it, right? But that's all you need for step 1. Okay. Notice here, we want to know if the mean odor threshold is significantly lower. We would like to know if wine tasters have a lower odor threshold than the general population, right? And so this is going to be your alternative hypothesis. Right? So if you're looking for a difference, that's when we use the just not equal to, right? And as a default, use not equal to. Right? On the test, I've made it one-sided because, as you'll see, it makes it a little bit easier. So you will want to figure out which way the sign should go, right? But because we only care about the mean being less than 25, right? So this is a lower odor threshold. I only care about one side, right? And so what I've got here is I've got a one-sided test. And remember, we just kind of sit on that until we have to find our p-value, because that's where it's going to come in. But what it's going to look like is, well, here, if I'm centered on 25, because that's what I'm assuming my mu is, right? I'm assuming mu is 25 until further notice. And then I found 21.5. That's my sample mean. Now here, this area in the tail, this is my one-sided p-value, which we find using the Z table. Okay. So we kind of got ahead of ourselves, but that's where we figure out, so we've, in the alternative hypothesis, that's where we figure out which tail we're looking for. Okay. So now we kind of parking lot that for a little bit, and we're ready to actually calculate our Z score. right? So, and same on your formula sheet, right? Follows with your Z-score. So essentially, for your hypothesis test, this is step 1, right? Filling in with this mu naught here. This is step 2, do the test, right? Where you actually calculate your Z-score. So they're both on there. And then we can find the p-value. So 21.5 is our sample mean. We've got our mean of 25, our hypothesized mean of 25, I should say. As a rule, right, we established that, okay, any Z-score beyond plus or minus 2 we'll consider extreme. Extreme now is going to translate to, well, I'm probably going to reject H naught here, right? I'm too far into the tails to say that, yeah, 25, that's where I'm centered, right? It's more likely that I came from a different population with a different mean. That was too much, but that's the truth. So we calculate our Z-score, right? And we know how to do that because we've been doing it a lot. Just remembering that you have to do sigma over root n, right? Because now we're talking about a mean score. And so we find a Z-score, rounding to 2 decimal places, of negative 2.74. I've got kind of like a little follow-up question there. We don't have to worry about that. But what if Z, or what if our X bar was 23, right? Then we would be closer. And our Z, I'm guessing I picked 23 because Z is within plus or minus 2. Right? But I'm actually going to ignore that for a little bit. So we found our Z, negative 2.74. Now, so this is all we need for step 2. What did I say here? All we need in step 2, just kind of highlighting all the things that you need, don't need to show me, right? But you do need to show me all these 4 steps. Okay. So now we've got a Z of negative 2.74. So now in our step 3, we're going to find the p-value. So I can use my Z table. Oop. I'm on the negative end. Oh, that's from before. And so negative 2.7, negative 2.74. So I'll just kind of trace across here. That's going to be the area in the tail, in the left-hand tail, right? So let's see here. So Z is negative 2.74. I can use my Z table to find the probability of seeing a Z as extreme or more extreme, right? Which translates to the tail. We find that the area in the tail is 0.0031. So what we've got, right? We're still centered on 25. We've got 21.5 here. This shaded area is the probability of something as extreme or more extreme. And so this is my one-sided p-value. Which is 0.0031. Okay. This little blurb. And it might be helpful to use that graph too. Make a quick little graph for yourself, but this is all we need for step 3, right? Finding the p-value. Just as a side note here, if I needed to find the 2-sided p-value, right, that's why I won't do that on the test, because it's this added step that I don't fun, you guys, right? But if we need a two-sided p-value, which means you have a not equal to in your alternative hypothesis, then we would take this 0.0031, multiply it by 2, and pretend that it happened up here too, right? And so if you get a positive z-score as well, right, even if you only want a one-sided p-value, right, then we know how to find the area in the tail, right? The table gives us the area to the left. We need to find the area to the right, so we use that 1 minus, right? And so that's going to be important, right? Here is kind of the simplest version where we're saying, okay, my one-sided p is on the lower end, right? Added step if we've got it on the upper end, if we've got a positive z. Good. Oh, and then here's my favorite. If the p is low, then the null hypothesis must go. How nice ring to it, right? So anyways, I think it's pretty funny and I don't know. Anyways, the number of final exams that I've marked where it's just kind of jotted down in the margin as like a memory aid is very funny because it's catchy. So, but it's also true, right? So, because we're heading into our conclusion here, and so we have to remember, okay, what do we do? If the p-value is small enough, then I can reject H naught, right? If the p is low, then the null hypothesis must go, right? And so, so you can use that to remember until it starts to make sense, right? Because what we're saying is that, well, if I've moved far enough away from 25, right? If 21.5, if the probability of seeing 21.5 when the mean is 25 is only 0.0031, right? It's not very likely that it came from a population, from this population, right? It's more likely that it came from a population where the center is closer to 21.5, or at least less than 25, right? And so for our conclusion, right, since our p-value is 0.0031, it's definitely less than our assumed alpha level of 0.05, right? I would either give you an alpha level, right, use this alpha level, but the default is 0.05. So if I don't give you one, it's 0.05. Which means we have enough evidence to reject H naught in favor of HA. Yeah.
Is the default still going to be 0.05 even if it's just a one-sided?
Regardless for if it's a one-sided or a two-sided test. Yeah, thank you. Good. So here, remember our conclusion has 3 parts, right? So you want to have a little checklist. So the first part is comparing your p-value to the alpha level. Is it less than or is it greater than the alpha level? Okay. And here, because this is our first time kind of seeing this stuff, right? If you tell me that 0.0031 is greater than 0.05 here, as long as you follow through and you're consistent, right? Even though that's an error, take a half a mark off or something like that, right? But as long as you follow through and you keep kind of stick with it, right? I don't want you flipping back and forth, right? And so here's kind of the first part of our conclusion where we compare it to our alpha level. And then the second part of our conclusion, what does that mean in terms of H naught, right? Do we have enough evidence to reject H naught or not? And then I've got some extra blur, blah, 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 blah in there. But we also have to state our conclusion in terms of the question, right? There's always a question. Is there evidence that wine tasters have a significantly lower odor threshold than the general population? And so here, our conclusion in terms of the actual question. So these three things are, I should put all in quotes because it's a lot, right? Your conclusion is going to be, I do 1 mark for each of those, right? So you don't want to forget your conclusion in terms of the question, for example. That's a big one. People say, okay, I rejected H naught, moving on. You want to tell me what that means, right, in terms of the question. And so I'll put quotes around all we need for step 4, right, the conclusion. So you're going to break it down to a 4-step process. You don't have to label the steps, but I do need to see all that work and all that thought process. Okay. So did you know? Well, any questions about that? Oh, before, yeah.
What is the confidence interval?
So here, are you talking about the note down below? Oh. Yeah. Yeah, so usually we do a hypothesis test, build a confidence interval, and we do those kind of in tandem. So the hypothesis test, right, what we've established here is that, okay, wine tasters have a significantly lower odor threshold than the general population. But that's all we're saying, right? We're not saying, oh, their odor threshold is somewhere here, right? We're just saying it's significantly lower than 25. What more do you want from us, right? Well, you might want to know, well, okay, so it's lower than 25. So what is it, right? And so that's where the confidence interval comes in, because that's where we took our 21.5 and we built bounds around it to try to figure out where their population mean might be. Right? And so that's what this note is about. We can actually use confidence intervals instead of p-values if you want to. P-values are kind of old school. You know, we have to teach them p-values, they'll never survive. But confidence intervals are kind of how we're moving slowly with the speed of academia. We're moving towards confidence intervals to test hypotheses. Because if I'm able to use a confidence interval and say, well, I'm 95% confident that the population mean is in here, right? And my hypothesis is that, or my null hypothesis is that mu is 25, for example, right? Then if 25 is in that interval, I cannot reject H naught, right? If 25 is outside that interval, I can reject H naught, right? Because my interval is not capturing that hypothesized value. So if we go back, you know, kind of scroll way, way back to our confidence interval here. Whoa. Whoa, Nelly. Okay. What we're saying after our confidence interval, and sometimes I do the hypothesis testing question first, then the confidence, it's just a spacing issue usually, so don't be thrown off if they're in a different order. But what we said for our confidence interval was that we're 95% confident that the interval from 19 to 24, right, captures the mean odor threshold for all wine tasters, right? So if I compare 25, which is kind of our general population mean, right, 25 is outside this interval, right? This is consistently lower than 25. And so it leads me to that same conclusion that I did with my hypothesis test, right? And so it's just 2 different ways of going about it. I'm going to test you on both, right? But ultimately, when you're out in the real world, you can use p-values, you can use confidence intervals, you could hire someone, I don't really care. So, and they'll use p-values or confidence intervals. Someone's going to have to do it, right? And so it may as well be you. All right, or me, give me a call, no. So, right, our confidence interval definitely lines up with our hypothesis test. there are a couple of scenarios. So a confidence interval, remember, is the central 95%. So often we're not going to be borderline, and so that doesn't matter. So just ignore me for that. Just forget I ever said anything, right? But so the confidence interval matches a two-sided test, but usually it's going to be the same. All right. Da, 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 da. Any questions? I'm gonna need some time with this. I know. We're just gonna finish with talking about decision errors, and then hopefully we have time to do another example, because I think that would be really good, especially for hypothesis testing. So decision errors, if I've rejected H0, there's a chance that I'm wrong. In fact, there's a p-value chance that I'm wrong, or usually what we say is there's an alpha level chance of being wrong as we set into this thing. And so your conclusion, right? I guess I shouldn't cut it off. You've got it in front of you, so. You've got two options, right? You can either reject H0 in favor of HA, or you fail to reject H0, right? So those are your two options for your conclusion after doing your test. There is some truth out there. We don't know what it is, right? But if H0 is true and you've decided to reject it, that's an error, right? And so we call that a decision error. And in fact, we call it a type 1 error, right? And so we've got these type 1 and type 2 errors. And I basically just memorize this table. I know that's not helpful, but if you've rejected H0, the error that you could be making is a type 1 error, right? If you didn't reject H0, then, and H0 should be rejected, then you've made a type 2 error. Right? So usually what I'll ask is something like, okay, so I make you do a hypothesis test, you arrive at your conclusion, and then I have a follow-up question saying, if your conclusion in the previous part was wrong, right, what type of error did you make? Type 1 or type 2? Right? And so it depends on your conclusion, and of course I'm going to follow through. So even if you kind of came to the wrong conclusion earlier, as long as you're consistent and you're saying, okay, I failed to reject H0, so therefore I could be making a type 1 error, right? And so if I reject H0, right, I could be making a type 1 error. Right? Basically, it's a false positive. Right, so if you want to think about it as a false positive, there's basically only one decision error meme. It's this doctor telling this old man that he's pregnant. Type 1 error, right? And then because it's a false positive, right? Like you're pregnant. To this old man, it doesn't make sense, right? We understand that that's a mistake. So that's a type 1 error. Or the alternative, right, is if we fail to reject H0, then we're saying, okay, nothing's going on here. This is a negative result, but we should actually be rejecting H0. Then we've got a type 2 error. So then the doctor is telling this pregnant woman, she's clearly pregnant, I'm sorry, you're not pregnant. What? So then we've got this false negative, right? And so if I fail to reject H naught, I could be making a type 2 error, which is essentially a false negative. Or a meme that I thought about using, but I just didn't have time to incorporate it. I saw this one where the doctor is telling the guy that he has COVID-19. He says, "How can that be? I have 300 rolls of toilet paper." Not really a type 1 or type 2 error, but it's funny. So anyways. Okay. And then I've got some more blah, 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 blah about type 1, type 2. But as long as you're able to tell me, okay, I rejected H naught and acknowledging that I could be making a type 1 error, that's good enough for me. Or I failed to reject H naught, I could be making a type 2 error. Right? And so, and I think that's part B of question 4 on your practice test. Any questions? No. I really didn't think we would get through all that, so I'm pretty pleased. Should we go through the practice test, or do you want to save that for later? I can always post it because I don't have any lined up. So how about we use this one, and then I'll post another hypothesis testing or another question for you later. How about that? Okay, so let's see here. Bless you. Question 4. I'm going to change my pen here. So you took a random sample of 48 Amazonian manatees and found their mean speed to be 4.4 miles per hour, right? And so you took a random sample, just because I don't have it to copy in here, random sample of 48 Amazonian manatees. With a mean of 4.4 miles per hour. Here, right, you want to start deciphering, okay, well, my N is 48. And their mean speed of these 48, right, making this a sample mean, is 44 miles per hour. So X bar is, or sorry, 44 miles per hour. Yeah, no wake zone. They're just ripping. 4.4 miles per hour, and we'll ditch units for a bit. Okay. It also says, assume it is known that the standard deviation of speeds for all manatees is 1.34 miles per hour. Okay, and so here, just as kind of a warm-up for the next types of questions that we'll do, right? So I'm going to break these down into kind of question types, right? So here, we're talking sigma known, since sigma we're saying is 1.34 miles per hour, right? So this is the standard deviation. I'll just do SD. SD of all manatees is what makes it sigma, right? Later on, right, I'll say you collected a sample of 48 Amazonian manatees with a mean of 4.4 and a standard deviation of 1.2. That standard deviation came from the sample, right? So that's where we're headed But I don't know what I'm gonna do when I can't use my hands anymore. Kind of show you what's going on. Hello, can anybody see me? We'll figure it out. Maybe I'll have a, yeah, no. Okay, so part A asks, is there evidence that Amazonian manatees are significantly faster than West Indian manatees who travel at a mean speed of 3.8 miles per hour? Right? So now we want to know, okay, so looking at the numbers, yeah, 4.4 is faster than 3.8. We want to know if it's significantly faster, right? And so is there evidence is kind of a clue that we have to do a hypothesis test. And so here, this is a hypothesis test. And our step 1 is going to be to state our null and alternative hypothesis. Your null hypothesis is on your formula sheet, right? It's going to be that mu equals mu naught. That mu naught we're going to replace with the value that we want to compare our sample mean to, right? And so here I'll say mu naught is 3.8. Right? So what I'm going to do is I'm just going to scratch that mu naught and replace it with 3.8. So you want to compare your sample mean to some value. So you have to figure out what that value is. And then your alternative hypothesis. Of course, if you just went to mu equals 3.8 for your null hypothesis, that's good. I just want to show you where it came from. We want to know if the mean of the Amazonian manatees is faster, so is mu greater than 3.8? We always have to talk about a parameter, so we have to talk about a population thing, right? So for now, that's just a mu, those have to be the same, but we also have to talk about the same value on this side, right? And our null hypothesis always has an equal sign. So the only thing that is really different between these two is the sign in our alternative hypothesis. And that's going to come from the question, right? It's going to depend on what the question is. So here we want to show that mu is maybe greater than 3.8 or maybe not. Maybe it's not significantly greater than 3.8. So then step 2, whoa. Yikes. We're going to calculate a Z score. So Z is x bar minus mu naught over sigma over root n. And like I said, you don't have to outline the steps. As long as you do all the things, doesn't matter. So Z is going to be 4.4, because that's what we said our sample mean was, minus 3.8 divided by sigma, which is 1.34, divided by the square root of n, which is 48. So 4.4 minus 3.8 divided by 1.34 divided by the square root of 48. I get a Z of 3.10218. But if anyone else did it, do you want to just confirm 80551? I feel like my finger slipped, but it's good. Cool. No, all our fingers slipped. Unlikely. I reject that hypothesis. Right? That's what we're doing here. So, nice job, guys. All right. So we've got our Z. Our Z is 3.10, right? We need 2 decimal places, and we have to round properly, right? And so now our step 3 is to find the p-value. So if we draw our curve, it's going to be centered on our hypothesized mean of 3.8. At this point, we've got our sample mean 4.4, which is actually Z equals 3.10 if you want. What is going on? We're on the top floor, right? I think, pretty sure. Not sure. So then we have to keep in mind that the p-value, the one-sided p-value is going to be the area in the tail, right? And so here we want this area. This is our one-sided p-value. And usually I'm a bit more of a stickler here, but for us, I think we can just go, because we're working on a condensed time frame here. Usually I want the blurb using the Z table. We find the area to the left of Z equals 3.10 to be this. And so the area to the right is this. So we can just, as long as you draw the graph and you show me where it is, then we can just go to the table. It's a little bit freaky, right? So 3.10, I get an area to the left of 0.9990. I might have said too many. No, I might have said too much. 0.9990. So the one-sided p-value is 1 minus 0.9990, which is, so 1 minus 0.9990. Of course, 0.0001. Or maybe it's 1, 2, yeah, sorry. Thank you. So that's our one-sided p-value. Here, this is the step where if you needed a two-sided p-value, right? If you had the alternative hypothesis is that mu is not equal to this thing, then you would multiply it by 2, right? But we have a one-sided test, so we just want to keep it as it is. So step 4 is our conclusion. First thing we do is compare our p-value to our alpha level. I don't think we were given an alpha level, so we're just going to use 0.05. Right. So we say something along the lines of, and this is another blurb that you can just memorize and use. So since our p-value, and I'll even go a little bit further and say, since our one-sided p-value of 0.001 is less than our, and I'll say assumed alpha level, since it wasn't given, alpha level of 0.05, we have enough evidence to reject H naught, oops, to reject H naught in favor of HA. And you feel like you're done, but you're not quite, because we haven't actually answered the question. So now if I'm rejecting H naught, then I'm able to say that therefore Amazonian manatees, and here you can just reword the question as an answer, Amazonian manatees are significantly faster. Amazonian manatees are significantly faster than West Indian manatees. And I completely almost forgot, we have to do these dang evaluations. If I made an error, right? If I've rejected H naught and I've made a mistake, what type of error have I made, right? To do part B here, type 1 error is what I could be doing. And I'll post the solutions. Any questions before we do these evaluations? Oh, okay, have you guys done these before? Okay, cool. Bye guys.